Hey guys, this is James again. I just wanted to bring you along for a bit of a troubleshooting journey that I've been on dealing with the Realtek drivers and my Proxmox 8.0 cluster. I wrote up a quick gist on GitHub. I just recently updated with some examples here, but the crux of the issue seems to stem from the driver that the Realtek NIC is using and the Proxmox 8.0 release. I talk about it here more in detail. Essentially, what I do to fix this is I update my sources list, adding different archives here for the firmware, and then I'm going to also install the PVE headers and the older DKMS driver here for the Realtek NIC. Then we're just going to blacklist the 8169 driver and update some grub command lines that I found to be helpful for the NIC and reboot. The reason we use the DKMS driver here is because this allows us to dynamically compile the driver every time the Linux kernel is updated. So we're free to blacklist our newer driver here. I talk through exactly what we're going on, what's going through, talking about the DKMS suffix, specifically how it works in the Linux kernel. I talk about why you might need the PVE headers and why it could cause an issue where your device will not come back online without them. I also want to bring you along with how I fixed it for my cluster here. So as part of this journey, I wrote an Ansible Role. The Ansible Role is quite a bit more involved, but it makes it easier for me to patch my systems going forward, along with allowing me to scan for the problem, detect and see if it is an issue, and then apply the changes if I need to. So this is what the role looks like. Basically, it's talking about the same kind of fix, right? It's documenting all of the issues and not referencing the gist directly, just because that's the manual way of configuring it. But we're going to step through the tasks here that we have and how I typically set up my roles. So the main YAML here is actually going to be kicking off the tasks, right? So all I'm doing is saying, hey, I want to include this apply Realtek fix task, apply the discovery task, or apply the repository task, right? And all I'm doing here is actually applying a conditional statement, basically saying, like, if you say you have a Proxmox subscription, then I don't want to adjust your repositories as you'll likely have these configurations already included. Then we're going to do discovery to make sure that you actually have the Realtek NIC present. And then if the Realtek NIC is present, we're going to apply the fix. So let's step through some of these YAML files here and we'll take a quicker look at what they're actually doing underneath the hood. So as mentioned in the repository YAML, we're actually going to be updating your repository to include a non-free and non-free firmware archive. While the non-free version is not always required anymore, I just like to have it there as a comfort factor, really. The non-free firmware version of the archive is actually the requirement going forward for the Debian distribution. Once this is finished, we're going to update the app cache. This is just to make sure you actually refresh your packages in your repositories and you can update the metadata associated to it. This essentially allows us to see the PVE headers and the DKMS driver. So now, stepping through the next part, we're going to go to the discovery. The discovery is just looking at your LSPCI input and checking to see if you have your Realtek driver along with a specific model here. We're then going to be grepping for the kernel driver in use and saying, okay, well, we only want to look at what the kernel driver in use is. We're going to set our initial fact to false. This is to make sure the role doesn't fail if the value is not set. I don't like setting defaults explicitly in line as they're a little bit harder to read, and I'll show you that a little bit in more detail in other roles that I develop in the future. But then we're going to check to see that the Realtek NIC is the 8169 Realtek driver. And if that's true, then we'll set the value to true. So if we have a NIC that needs to be patched, we're going to actually apply the Realtek NIC fix. And what this is actually updating the app cache again, just in case your repositories didn't get updated in the future. We could probably remove that, but I just like having it as a built-in all-in-one view. We're going to then install the PVE headers package. This is for Proxmox to make sure you have the right pointers to the Linux kernel. We're going to install the 8168 driver for the Realtek NIC. We're going to use the DKMS version, again, just to make sure that we can recompile in case the Linux kernel gets updated in the future. And then just as a cover all, I like to update all packages here. Usually I'm installing this right at the beginning of initializing a new node. So I just want to make sure my node is coming online with all the updated packages. The last bit we're going to do here is actually update the grub parameters and make sure that our grub is actually set with the proper Realtek NIC parameters that we mentioned earlier. And then we're going to check to see that we want to update the grub configuration. Now, what I do here is I actually make sure I register my grub parameters, that if this changed and if we actually modified grub, then I want to do the reboot and the tool refresh. So basically, this is just making sure that you don't have to reboot if you don't need to. So if these settings were already in place, you may not need to reboot. So I'm just going to leave it alone. And at the end here, we're just updating the Proxmox boot tools list and then rebooting if needed to. And that's pretty much it. So this is an easy way for me to update all of my nodes all at once and bring on and onboard new nodes if I acquire new hardware in the future. And this is something that allows me to scale. So now in the next part here, I just want to show you what it looks like when we actually run this playbook against one of the nodes that I haven't fixed yet. So now that we are accessing the terminal, let me show you the Realtek playbook that I have here in place just to show you a demo of how this works. This is also referenced in the role README on the GitHub repository. That'll be linked in the description below. The playbook is actually pointing to the Proxmox host group that I have here. However, you can point it to a specific host just by referencing the host name here in the playbook YAML. Now, how I've been doing this currently is because I didn't want to modify my root password yet, is I've just been prompting to enter in my root password, and I'm just using the Ansible root user to log in here. Now, what this essentially does is it will prompt you for your password to log into the web UI. That way you don't have to configure it in a playbook or anything like that and potentially commit it up. This allows you to input secrets, things like that. I didn't want to kick in Ansible Vault here because I'm just not to that point where I deemed it necessary to actually have a bunch of secrets stored here. For right now, my use case is just to have a Ansible password be passed in to the root user and then SSH over to all of my hosts. So now I have a configuration here set up in my make file that allows me to kick off specific playbooks if I need to. So for me, my command to kick off this playbook will just be make proxmox-realtek, and this will kick off a run script that runs my Docker Ansible host, and we're going to be passing in all our configuration, our host files, things like that. I'll do a later video discussing that a little bit more in depth in the future, but I just want to make sure that this is not held up by the whole video. So basically all we're doing is running an Ansible playbook command and then passing in that Realtek YAML that we just looked at. So now here's the prompt that you'll get for the remote user password. In this case, it'll just be the root user password, and we're going to type that in. So now you see it'll go through the host and actually gather all the facts. And because I've patched all of these hosts already, we're going to just make sure all of our repositories are up to date. And then from there, we are going to probably just exit out because it will not detect a Realtek driver that needs to be patched. So as you can see here, it skipped all of the fix Realtek job because of our parameters that all of our NIC present is set to false instead of true. If this was set to true, I'll show you what it looks like here in a second. But all of the ones that are set to true would have kicked off the specific fix YAML to update those hosts. Now this makes it easier because now I can validate that all of my hosts have been fixed and that all of the configuration is in place for my host to stay online. Now, I don't believe that you'll need to modify this variable, but it's very important to bring it up that this is only controlling our repository configuration for our no subscription models for a non-free firmware archive. If you have a subscription and you found that the repositories still work for you and you don't have to modify anything like that, then this would be great to know, and I can update the role to include this value and maybe just eliminate this variable from the configuration. Feel free to make either a comment down below or submit a PR to this repository. And again, I'll link this in the description. Now, one last thing I want to show you before we end this video is just a run through of the playbook where it did detect that a Realtek NIC needed to be patched. And we're going to show you that real quick here. Of course, I'll speed this up as the process is going through, but I just want to make sure that you can see what it'll actually look like if there is a change detected that's needed, and then how it patches it and updates it. Now, what will happen is at the end of this role is that we will exit out once the server is starting to reboot. We will not actually wait for it to come back online. So if you need that in the future, or if you're planning on adding a another role that needs to run in sequence, you might need to add a pause timeout or wait until the host comes back online before you kick off your next job. Otherwise, you can run into issues where you'll just get an error that the host is unreachable. So this is what I have for this video. This was unplanned and a little bit shorter than my normal videos want to be, while I still hope it was as educational to solve these problems in the future and how I would approach it as a DevOps engineer that may be rolling this out to a data center or something that may need to be patched on a larger scale. Now, in my Proxmox cluster, I have 7 hosts right now, so there might be a need to have this role built out for me. However, if you're just running one node, using the script repository that I mentioned at the beginning of this video instead of using the Ansible Role would probably be a better choice, as it could be faster. However, it's always fun to play around with new technologies if you've never done Ansible before. Their documentation is actually pretty fantastic. They have a lot of examples and a lot of configurations you can do to set up your own playbooks if you want to configure this in the future. And again, if you've already patched it, there's no harm in running this role again, as it should detect that there's no issues detected on your system and just not apply any configuration changes to your system. If you appreciate the behind the scenes look at what's happening and how I've troubleshot my Proxmox cluster when I ran into an issue, please feel free to hit that thumbs up button. As always, I'm James. Have a good day.